kick the festivities off, we got to switch laptops here. Just keep this like this. Oh, there we go. Anyways, welcome. This is the Honeynet Project's presentation. What we're going to be talking about, and mainly the folks sitting up here, the Honeynet folks, is the latest advances in Honeynet technologies. I'm trying to switch laptops here. Yeah, that one's having, we're having problems with this screen on the side over here, so you may want to go ahead and move to this side over there. We'll see how things work out on that one. Okay, my name's Lance Spitzner. I'm going to kick things off this morning, and then as we get moving along and get into the more advanced geeky stuff, we'll bring up the real geeks and talk about the latest advances in Honeynet technologies. What I'm going to start off with is who we are and what we're all about and what we've done for you lately, as Ed stated over here. When we introduce ourselves, let you guys stand up. Did K2 ever show up? No, either in jail or passed out. Okay, I'm going to go ahead and these are the key players that we're going to be actually presenting today. My name's Lance Spitzner. I do Honeynet stuff full-time now. And as Ed put there, what am I, the pimp and whip whacker? Whip cracker, whip whacker, that's real good. That's getting recorded too, that's not good. My job's to lead and organize. I'm not as nearly as geeky as these other guys. Ed, go ahead and stand up. He's the Sebek 2 guy. He's the one that's going to be demoing some very, very cool new technology. Rob McMillan, believe it or not, captain in the Marine Corps. He's one of our lead coders. If anybody's played with Snort Inline, that's him. And then we got Bill and Patrick McCarty, the McCarty brothers. Well, actually dad and son. But the video you just saw was developed by his son, Patrick McCarty, which is up and available on our website. All right, these guys are the ones that are all going to be doing the talking today, filling you in on all the wonderful things that we've been doing. Okay, real quick, I'm going to start off with a general introduction on what the Honeynet Project is, what Honeynets are, and then we're going to give you time for these guys to talk and demonstrate the real meat of our new technologies. A lot of exciting things coming on down the pipe. So like I said, I'm going to cover over real quick what the Honeynet Project and the Research Alliance is all about, a little bit about Honeynets. Then Ed's going to go into this new open source technology we've released called Sebek 2 and some of the goodies coming down the pipe. And then if we have time, we're going to demonstrate another user interface for data analysis, and then Rob can talk about our new bootable CD-ROM. Basically, we've got so much new stuff coming out in the next 3 to 6 months, we could sit here and talk all day. And that would definitely put you out of sleep. So what we're trying to do is cram all this stuff into an hour, and we're not sure how much we're going to be able to cover. Hopefully quite a bit. Okay, the Honeynet Project. We'll go ahead and cover this rather quickly. Many of you potentially have heard of what we do. The big problem is how can we defend against a threat, an enemy, when we don't even know who the enemy is? We're all taking a variety of classes, learning about a variety of technologies to defend against a variety of threats. How can we defeat that threat when we don't even know who the bad guy is, how they operate, and why? That is what the purpose of the Honeynet Project is. It's an all-volunteer organization. All of us up here are all volunteers. Security professionals dedicated to researching these cyber threats. How we learn about these bad guys is we deploy networks around the world to be hacked. Just like you saw in that video, we're deploying these networks. Bad guys break into them, we learn about them. So the big things the project are working on right now is developing these networks so they're very easy to deploy, but very hard to detect from the bad guys. We have a mission statement. The mission is to learn the tools, tactics, and motives of the Black Hat community, but the most exciting part is share the lessons learned. So we share everything that we've captured, learn, and how we learn it, and that's in fact part of what we're doing here today. We have 3 goals. A, to develop awareness. The vast majority of the internet community is not aware that they're a target. Every one of you is aware because you are here learning. But you'd be surprised how many people don't realize their cable modem or their DSL connection is a target. Information. For folks like you who are aware, our goal is to help teach you more on the bad guys, how they attack systems, why, the organizations, things along those lines. And finally, for those of you that want to deploy your own honeypot or Honeynet technologies, we share with you all the code we've developed, how we use it, the lessons learned, our mistakes, how we've screwed up, things along those lines. We began in '99, called ourselves the Honeynet Project in 2000, and started the Honeynet Alliance in 2002. It wasn't like, we're going to start this major corporation with this intended purpose. It started very slowly progressing and growing over the past 4 years. The interesting thing of our value of the project is we're totally open source. We release everything we do. Release the source code, what we've learned, how we've learned, stuff like that. That's what motivates all the team members, because what we're doing, we hope, helps. Everything we capture is happening in the wild. There is no theory. There is none of this, well, the bad guys could be doing this, they could be doing that. Everything we capture and release has been done by real bad guys in the real wild internet. Made up of security professionals around the world, so you get a real global perspective. Folks from India, Brazil, Ireland, Singapore, things along those lines. Because as we all know, the internet is one big global picture. And finally, we really have no agenda. We have no product, we have no services, we don't even have any employees, which means we have no revenue. It's a really lousy business model, but the guys really enjoy it a lot because we can get a lot done. It's a really non-profit 501c3 organization, so that means if you really want to donate anything to us, it's tax deductible. So if you got any of those crays you're just dying to get rid of, we'll be more than happy to take them off your hands. We've got a real board of directors, including folks like Jennifer Granick, Bruce Schneier, Al Huger, Marty Resch, Bruce Schneier, George Kurtz. No more than 2 members from any organization. So no more than 2 members from Cisco, 2 members from Sun, 2 members from any other organization. This makes sure that we're not unduly influenced. It's a real diverse set of skills. Not only do we have geeks, but statisticians, PhDs in psychologies, exploit hackers, stuff like that. So it's a really weird mix. And then we really work virtually from around the world because we are global. Now we have the Honeynet Research Alliance, started that in 2002. Other organizations want to deploy their own Honeynets. If anybody here is interested in deploying and learning about the bad guys, the Research Alliance is a great place to start. You can learn more at honeynet.org/alliance, and that's where organizations, create a forum for organizations to share information about how to deploy Honeynets, how to share information, things along those lines. And here's a list of some of the more recent Alliance members. And you can tell from the screen here, it's really a global organization. And that's what's really exciting about this. 2 new that just came on is Pakistan. They just came on recently, and Germany is going to be coming on very soon. Okay, Honeynets. I'm going to cover a high overview of this technology, and then I'm going to let the real geeks that do the coding and development come on board here and explain what's going on. A honeynet is nothing more than a type of honeypot, one type of honeypot. So it's not like there's honeynets and then there's honeypots. A honeynet is nothing more than one type of honeypot. A honeypot is a security resource whose value lies in being probed, attacked, or compromised. You want the bad guys to interact with it. Totally different from most other security technologies. The honeypot is, by definition, something you want the bad guys to touch, to talk to. It really has no production value. So this means anybody interacting with the honeypot is a naughty person. There's a problem. They shouldn't be interacting with the system. So anything coming to the honeypot is most likely a probe, attack, or a compromise. Anything leaving it is the system's been broken into and the bad guy's going out to the net. A honeypot does not even have to be a computer. It can be a record in a database, an Excel spreadsheet, PowerPoint slides, research and development documentation. But it's all bogus stuff that nobody should be touching. So it can be as simple as putting a Microsoft Word document in your file server. And if somebody's accessing it and trying to read it or things along those lines, they're doing something naughty. So honeypots are really a very flexible tool. They're not a specific solution that solves a specific problem. They can be used for detection, incident response, information gathering, smoking out an insider, things along those lines. So that's why you see so many different manifestations of honeypots. The big advantages of honeypots is they collect very small data sets, but data of high value. Instead of getting 100,000 alerts a day, you get 100. Instead of a terabyte of data a day, you're getting a meg a day. But it's all data of high value. The problem a lot of us face is the needle in the haystack. Well, with honeypots, everything's needles. You just pick out which needle you are most concerned about. You really reduce false positives. Now, that's one of the big challenges we face. Many of you probably get 10,000 alerts a day, but you try to figure out which ones are the real ones. With a honeypot, everything's a real probe or an attack. Now, you can also catch new attacks, new motives, new techniques, IPv6 tunneling and IPv4 to obscure traffic, and so IDS systems can't detect it. Encoded IP11 packets for backdoor communication. There's a lot of new and exciting things you can capture. Now, this is very critical. They can work in IPv6 or encrypted environments. Many organizations are going to encryption. How do your detection technologies work in an environment like that? For honeypots, not a problem. DoD, big push now in IPv6. Honeypots, not a problem. And they're a very simple concept. Now, like any technology, honeypots, including Honeynets, have the disadvantages. Everything has pluses and minuses. Some disadvantages being honeypots only see what's going to and from them. It's kind of like a microscope. You know, very small, narrow field of view, but a very detailed field of view. So honeypots work with other technologies. And then some honeypots, especially high interaction honeypots, and especially Honeynets, which we're about to talk about, come with risk. The risk of the bad guy breaking into the system and using it to attack other folks. A lot of ways to mitigate it. Some examples of honeypots. Honeyd. How many folks here have heard of Honeyd? I'm just curious. Okay, most of you. All right, this is, all right, you guys are, yeah. We got a lot, I'm probably repeating a lot of stuff here. But most of you folks have heard Honeyd. You're definitely up on the honeypot stuff. One of my favorite honeypots, open source, Niels Provost developed it. Very powerful. Niels is developing a lot of new features for Honeyd. For example, SMTP spam catchers that automatically feed information to black holers. He's got a lot of other stuff that he's testing out. The only reason he hasn't done a lot of releases is he's now defending his PhD thesis in July and August. So after that, expect a lot of new and exciting things to come out from Niels. Some others, you got Spectre, or another commercial, KF Sensor, Mantrap by Symantec, the closest thing to a Honeynet. NetBait. That's a honeypot farm. If I get a chance, I'm actually going to be talking about honeypot farms in my class this afternoon. This afternoon, I'm doing all the new future and advanced things for honeypots, where basically you create entire farms of honeypots. And then Honeynet. Like I said, it's only one type of honeypot. Here's Honeyd. How does Honeyd work? Honeyd monitors all of your unused IP space. Any connections to unused IP space then interacts with virtual honeypots. So a single computer can literally monitor an entire Class A network. Niels and Doug Song tested this on a Class A that the DoD gave them for research purposes. So Honeyd and working with ArtD, very powerful, very cheap, simple solution. Now here's Lance pimping his book. If you want more on honeypots, then check out this book. For those of you that saw Richard Salgado, Richard Salgado wrote chapter 15 on this book, The Legal Issues of Honeypots. Okay, enough about honeypots. If you want to learn more, I'll be doing a class this afternoon on them. Let's transition to honeynets, one type of honeypot. A honeynet is nothing more than one type of honeypot. It's a high interaction. High interaction, we provide real operating systems for the bad guys to interact with, as opposed to low interaction honeypots, which only emulate services. So the advantage here is we can capture vast amounts of information. It's an architecture. It's not a product. It's not something you just boot off a CD-ROM. Rob's doing much work to change that. We're hopefully going to have a bootable CD-ROM soon. Hopefully we can talk about it. But it's an architecture you build and you populate this network with systems to break into. So we create a very highly controlled network and then capture everything going in and out of the controlled network. If you're interested in learning more, URL at the bottom. Actually, the best way to learn is our new Gen 2 paper that we released a couple months ago on the second generation Honeynets. Far more powerful Honeynets in that they're much harder to detect, much easier to deploy, and much easier to maintain. Excuse me. There's two critical elements, data control and data capture. You're not worried about data collection unless you have lots of Honeynets out there, more than one. Data control and data capture are what you need to implement. This is a Gen 1 Honeynet. I really don't want to go into this. Let's move on to the cool thing, the Gen 2. Just real quick, with the Gen 2 Honeynet, what we're doing here is this. is you see the systems on the bottom, the yellow systems. Those are the honeypots within the Honeynet. The system, do we have laser pointers anywhere? No laser pointer. Okay, you see the system on the right with the red dotted lines. That's the layer 2 gateway, the bridge. That's what allows the bad guys to come in, captures everything they do, and then controls what they do outbound. It's kind of like the Roach Motel. You let the roaches in, but you don't let them out. The trick is capturing everything they do without them knowing it, and then letting them go out and do whatever they want without them hurting anyone. Now, how do you capture everything the bad guys do? Bad guy goes in using SSH, IPsec, SSL, gets on your honeypot, uses SCP to load up a BurnEye encrypted rootkit, launches the BurnEye encrypted rootkit, takes over your system. Now, so he's using BurnEye, over encryption, things along those lines. How do you capture absolutely everything the bad guy does without him knowing it? Easy. You use Ed's little toy that he's going to talk about in about 5 minutes. This guy's developed a solution that'll capture everything the bad guy does, keystroke by keystroke, byte by file byte upload, encrypted IRC chat sessions, BurnEye, things along those lines. No longer a problem. You do it on Windows, Solaris, anything along those lines. He's got the solution. He's going to be talking about it in 5 minutes. Now, the other really neat thing is the gateway. This thing right here that controls what the bad guys do, inbound and outbound. That can be a pain in the ass to build. Our papers explain step by step how to build it. But it's do compile this, add this, put in that, put here, put there, things along those lines. What Rob has developed, and we've already got a beta playing with people. If somebody's interested in playing with some very beta technology, oh, cool. I'm going to borrow your laser pointer. Thank you, sir. So that being the gateway right there, what Rob's developing, like I said, the captain in the Marine Corps who actually knows how to code preprocessors. Scary stuff. But what he's developed is a bootable CD-ROM. Stick CD-ROM in computer, it instantly becomes a Honeynet layer 2 gateway that controls everything the bad guys are doing. So what now used to take 2 days takes 2 minutes. So now the idea being making Honeynet's much easier to deploy. That's what Rob's working on. So there's a lot of neat and exciting things. So the whole idea of a Gen 2 Honeynet is a layer 2 gateway, allows the bad guys to come in, capture everything the bad guys do, and then control what they do outbound, all without them knowing it. And the big problem we had was how do you capture everything they do when all the bad guys go totally encrypted? Ed's got the solution. He's going to talk about it in a couple minutes. And like I said, the fun stuff is this is all open source. It's all on our website, honeynet.org. I'm just curious, anybody here actually ever tried to build and deploy a Honeynet? Anybody? We got, oh wow, okay. 3, 4 gutsy folks. They are time consuming. One real quick slide here. This is something that Rob McMillan, once again, the Marine, developed, is how do you allow the bad guys to go outbound? Easy. We use something called Snort Inline, modified version of Snort. When the bad guys launch an attack outbound, we disable it. So in other words, if the bad guy hacked one of your honeypots and launched a DNS exploit, look what we just do. This is a standard Snort alert, but what Snort does in gateway mode, all we've done is convert Snort into an intrusion prevention system, is, hey, when you launch this exploit, I want you to go ahead and replace the exploit with the binary information here. We've just disabled the exploit. And God forbid the exploit still actually works. Well, when the bad guy gets on the remote system, launch BenSH. How many Unix systems do you know have BenSH? So what's just happened here is this. Yeah, I keep running up and down here. Good workout. Is this, though? What the hell, man? Fix your slides. Get up there and you fix your slides. So what's just happened is Lance screwed up the slides, and Ed's going to fix them. No, what's going to happen is, think about it. The bad guys launch exploits. We want to allow the bad guys to go out and to do as much as they want outbound. But with that new Snort Inline functionality, what you saw there, I went like to a different presentation.
Yeah, no, I cut over to the Sebek thing. That's where you told me. That's where we trimmed it.
Oh, all right, all right. Oh, okay.
Or I probably.
Okay, go back to the. It's there. So, like I said, when the bad guy launches, we now let the bad guys do whatever they want outbound. But if they try to exploit somebody, we disable the attack. So the bad guys see their exploits going out, and they come back failed, and they don't know why. It's because we modify it as it goes outbound. All this code's already released. And you can actually use this to protect your systems from inbound attacks. But at the Honeynet Project, we're all screwed up. We allow people to come in and attack us. We just make sure they can't go out and hurt other people outbound. Now this was really fast and furious. A lot of everything I've just covered is well known. It's published in all our white papers, things along those lines. The reason I did this fast and furious is I want the guys to come up and talk about what isn't released yet, because this is what's coming down the pipe in the next weeks and the next months. So if you have any more questions on Gen 2 technology, like I said, it was fast and furious. A, you can go to our website, honeynet.org, and read the Gen 2 paper. B, come up afterwards and beat us up with questions. And that's what we're all going to be here, or beat us up with questions after the presentations. But what I want to do now is hand the presentation over to Ed. Ed's going to talk about Sebek 2, how you can capture everything a bad guy does, keystroke be keystroke, on your computer, even though they came in totally encrypted, and how you can capture it all without the bad guy ever knowing. And then hopefully, if we'll have time, we'll have Rob talk a little bit about the bootable CD-ROM, maybe even demo it. Oh yeah, oh yeah, shoot, that's right. We even have a booth. If you go all the way in the back corner where all the food is, we have a booth there, so you can beat up. We'll be more than happy to demo stuff. All right, so you at least half an hour. Oh, here we go. And we got the geek handoff. Yep.
Does that sound good? Okay. Yeah, first I'd like to introduce myself. I'm Edward Bayless, and I work at Indiana University, specifically within the Advanced Network Management Laboratory. And my tasks basically encompass anything that's related to network infrastructure protection. And I've been sort of a part of this project for, I don't know, about a year or so. And I've done a lot of stuff related to data collection specifically. As a show of hands, how many of you ever had a situation where a host was compromised and the intruder installed their own version of SSH and started doing a lot of activity over that secure channel? Has that ever happened to anybody in the crowd? Okay. Did you ever figure out how to get the keystrokes? Okay. So about a year or so ago, I had a pretty interesting event where one of my honeypots was broken into. And it rapidly became clear this was going to be a very fun one to watch because the intruder broke in, immediately installed their own version of SSH, turned around and started DDoSing a couple people out in Romania. Unfortunately, I got the gist of what was going on there, but the fact I couldn't see the keystrokes kind of got me a little riled. And that's where this thing called Sebek started off. So with that said, with where my mindset was and how I got involved in all this, I kind of like to, start off now talking about what Sebek is and what it can do for you. Basically, it's all about observation. And the main goal is, how do you go about observing an intruder without them knowing they're being observed? I'm sure everybody's probably read the Cuckoo's Egg by Cliff Stoll. Well, in his adventures in Berkeley, he monitored the serial lines. I think he ran right to a printer or something really, really old school to get the data. But that's fairly reliable because it's hard to detect the kind of passive data collection. And today, basically our approach for data collection is similar. We now use networks, packets, and ethereal, TCP dump, whatever. We use live PCAP-based tools to collect that data now off of Ethernets or serial lines, whatever. And that's great. It's fantastic. You use tools like Ethereal. You can extract, FTP file transfers. You can do TCP session reassembly. You can get HTTP file transfers as well. It's great. But the problem is, of course, well, what do you do if the intruder, or anybody in that case, uses session encryption to protect that file transfer or that communication channel? You basically have two options. Do you brute force the encryption, or do you find a way of circumventing it? Now, I'm pretty lazy, so I initially said, I'm no cryptanalyst, so I'm going to look at circumvention, see if we can figure out a way of doing this. So Sebek was basically born out of the desire to observe the intruder when this encryption was in use without having to break the encryption. That's sort of in a nutshell what it does. How it does it is it operates as a kernel module, or more generically, it operates within kernel space, and it collects forensic data of interest to researchers. Once we gather that data, we invisibly, I'll use quotes there because nothing's perfect, maybe we subtly, perhaps maybe a more accurate way of describing that, export this data to a remote data collector. The types of data we can collect with this, and I'll get into details of how we do that very shortly, we can get keystrokes. We can get file transfers using SCP. We can get BurnEye passwords. We can get the BurnEye file transfer itself, and a lot of other interesting things. This is actually, it opens up a whole panacea of research topics and interesting data that we're just now getting a grasp on. I'm not sure how many of you were here last year, so what I want to do now before going into the nuts and bolts is start to talk about what's changed, so I don't put anybody to sleep thinking this is the same old story. What has changed in the last year is, well, we have in operation, along with the Linux version, we've got an OpenBSD port that's almost complete. I believe we have a Windows XP port that is almost complete, and we have a Solaris version. And those are all in a variety of states of completion, and we hope to have them all complete by Black Hat Federal would be the goal, I think. Further, we've changed the way we've done things since last year. We have new packet hiding techniques we've added. We now record all data that goes to the read system call, and the entire system resides in kernel space now. And we also have this new web-based data analysis tool that we'll talk about. So what I also like to do now is talk about kind of, it's not a one-man show here. There's a variety of people that are collaborating on Sebek, and I'm just one of them. I do the Linux version. I also do the data analysis web interface. There are a couple other people that also help. Joop de Haas works in the Solaris version, as does, I think, K2 to some extent. Mike Davis has been working on the Windows XP port, and Dragos has been working on the OpenBSD port. The original version, as of a year back, was based on the Adore rootkit, and was coded initially by Michael Clark. What we wanted to do is we took a rootkit and said, why don't we turn the tables on the hackers and use their technology against them, essentially. And so that's where the technique of using a kernel module that was the nexus of that concept, really. Within the Sebek design, we have two components. It's pretty straightforward. We have a client, basically generates data, and it exports it to the server. And the server sits there, perhaps in the honey wall or somewhere else, and it passively extracts those records off the network. I'm going to talk about just the Linux design for the client because I'm not an expert in Solaris or OpenBSD or any of the others. But essentially, it's implemented as a Linux kernel module. And like I said, the original version was Adore rootkit based. That is no longer true for this new version. What Sebek does, it records all data that passes through the system read call. So anytime you want to access data on a system with the sysread call, we basically Trojan that call so we can get all that data, is what we're doing. And there's two options. You can either collect only keystrokes or you can record all data, period. If you want to do file recovery, you're going to need to record all data. And so the question is, well, how do we go about getting this data? And so what we do is we take a look at the syscall table, and we identify basically where the pointer is in that table, and we modify that to point at our version of the read call. When somebody makes a read request, system call, basically our code's executed instead of the original. And at that point, then we have a snapshot of that data. It looks something like this. And I guess if I had, I won't bother with the pointer, but you can see essentially, the user would come in through the standard library, and then would cross the kernel boundary, as it were, to do the read call. Unbeknownst to them, and they have really no easy way of detecting this, unless they can see inside the kernel, which there are ways of doing. What happens is basically that call gets relayed down to our own version of the read, and we make a copy of the data and send it down to a data logger. It's a pretty straightforward technique. Data export, what we do there is, and this is some relatively new stuff here, how we go about doing this. This did not exist a year ago. What we do is the Sebek module creates its own Ethernet frames, IP headers, UDP headers, generates them raw. It does not use the stack in any manner at all. It then bypasses all the filtering and raw socket and sniffer capabilities in the kernel by essentially sending that packet directly to the device driver, the hardware device driver. And so we end up basically just bypassing all those code paths that would allow somebody to either sniff those packets or filter them using IP tables. So that might look like this, where the blue box is essentially the network device driver that's sort of in the bottom half of the kernel. And once we send a packet to that bottom half module, it's pretty much immediately on the Ethernet. So you can see here, basically you have no capability of sniffing that packet, and there's no capability of filtering the net filter because we inject the packet after those code points. The other little thing we added was we also modified the raw socket implementation. And what we do is essentially we tell the new implementation, if you see a packet that happens to look like Sebek, silently ignore it. The reason we did this is to make sure that if there are multiple honeypots on a LAN, we want to make sure that honeypot A will never see honeypot B's Sebek traffic. Because we don't want to disclose this the whole Honeynet might be rigged, right? We want to keep this stuff looking plausible. So we have to hide not only our own packets, but packets from other Sebek hosts. And there are a variety of situations where, even if you're using a switched LAN environment where you can do things like cause the switch forwarding tables to become full and they start broadcasting frames, or there might be a switch forwarding table timeout on a specific MAC address. So there's a couple of situations where even if you configure everything correctly, packets from A might go to B even though they shouldn't. And so we want to make sure we protect ourselves from that situation. Once we talked about sort of how we generate the packets. What I want to do now is talk about what we do with this data and how we format it. And essentially all we do is we throw in a UDP frame, and basically we put one Sebek PDU, protocol data unit, in each packet we transmit. And basically, like I say, the packets are generated entirely within the Sebek module, and they use a static IP to MAC mapping you have to configure at the time you install the module. That makes sure that things like ARP spoofing and whatnot won't affect our ability to log data. The format itself, basically we've got a fixed length header, a variable length body. There are 10 fields in the head, and the payload is essentially the binary read data that we just snarfed out of the read call. Here what here's what the header format looks like. We can see there's basically your standard things, timestamps, some counters that let us know if we've lost packets, what PID the read was made on, what user ID was involved, what file descriptor, basically any kind of metadata that relates to the context of the read request at the time that it was made is recorded. And then also the first value, which is sort of interesting, is this thing called the magic value. And the magic value is added to allow us to identify which packet should be hidden. That in conjunction with the UDP port numbers. So some other features that I'd like to talk about too is, Sebek, the original version, the original version had a problem with some of the newer versions of Red Hat that didn't export the syscall table to kernel modules. Well, we figured out a way around that, and it's a fairly common one borrowed from, I can't remember which rootkit, but essentially if you don't export the syscall table, we'll still find it, is the upshot. Sebek is also, it hides itself by modifying the linked list in the kernel space for the linked list of kernel modules. We modify that to basically wrap that around us. So essentially, once we hide ourselves, an LS mod or any of those other kind of utilities won't see us and aren't able to remove us. Further, in this new version, there are no log files. There are no user space modifications required. There are no processes running. It's all in kernel space. So for those that may be in the future wanting to use Sebek in an environment, there are a couple things I wanted to mention as far as some tips here. Mostly, make sure you delete your tarball and scrub the memory buffer of the file system, or better yet, put it on a CD-ROM, install it from there, and unmount the CD-ROM. Just common things. Of course, also, if you're running bash, turn off your history, that kind of thing. You don't want to make it easy for an intruder, right? I mean, it's standard stuff. And forensics works two ways. The server side is a pretty simple beast, actually, although it does some very enjoyable things. Basically, it just captures Sebek packets. It'll then throw them into a MySQL database in the latest version. And then we have a soon to be released. All this stuff that I'm talking about here has not been released to the public. It will be in about 2 weeks, I think. Basically, we have a web interface that we can use. Then once the data is in the MySQL database, we can use this interface to look at this data now. And so what I want to do now is kind of go through a workflow of how you might use this data this data analysis tool to actually watch somebody that has broken into a host. And so what we have here is an example where a non-root user of UID 500 copies a file from a remote machine that was initiated from a remote host, copies that file to the local file system. It just so happens that that file is a Bernai protected copy of the pchoice exploit. The user runs that exploit, of course, and gains root access. So the question is, what can we do about this? What do we see when we're using Sebek? And especially if we presume, in this case, that all communication was over an SSH channel. Without Sebek, we'd be entirely blind to all of this. So the analysis questions I like to ask are, well, for one, can we recover the SCP file? Second, can we determine what the password, what password was used in the Bernai binary to activate it? And then lastly, can we identify exactly when that binary was run and at what point they gained root access? So this is what the interface looks like. This is the summary view. It's basically just has a list of the hosts running Sebek, total number of records that happen to be stored for that given host, and the last time we saw any activity on that host. So in this case, if you were to click on the little blue button that says keystrokes, you would get something that looks like this. And what this shows us is essentially a summary view for all the active file descriptors on that host. It'll show you the last 5 basically commands entered or keystroke lines entered for all those file descriptors. Now, also of interest is not just strictly keystrokes. As you can see here, the SCP process showed up and with something that looks sort of suspicious. So we're going to drill down on that because that one looks sort of interesting. And what we see here is we click on that, we see, all right, well, if I do a text view on file descriptor 0, I do a text view, it looks kind of weird. It looks sort of like a bunch of binary data with some plain text at the first line. Well, it just so happens that's exactly the signature you'd be looking for if that were a file transfer. And sure enough, the system actually tells you, yep, that's a file transfer. So if you click on the SCP file transfer button, it'll tell you the size of the file, the permissions, I believe is what it's telling you there for the file that's transferred, and then also whether or not we lost any data. Oh, laser pointer. Yeah, laser pointer. But essentially here you see here the data lost. And that's a pretty important one because, again, we use UDP. So one of the inherent limits we have is there's a good chance we may lose packets now and then in light of congestion. So if you start losing data on a file transfer when we archive it like that, you're not going to be able to recover the full file. But in this case, happy day. Of course, we got the full file. It's funny how that works when you're in a demo environment, right? So let's presume now that we've downloaded this application called malware, and of course the first thing any good reverse engineer is going to do is run strings on it, right? So they run strings on this binary, and sure enough, the phrase Tesso Bernai alpha encrypted engine shows up. Well, okay, that's a red flag to me. That's a Bernai file. Further, as you can see there, what we do there, right? Further, once you see that, you know pretty much if it's a Bernai file copied, you better keep your eyes open for this puppy because that is most likely malicious software. So next thing we can do is, okay, well, I know that they copied this malware application. Did they ever run it? So what we do is we basically go here to the search interface and say, okay, do we ever see the command malware executed? Fire it up. Sure enough, we have 2 instances of it running. We have one at PID 1315 and one at 1318. Most likely there was a fork involved is what I'm guessing there by the times. So if we drill down, what we want to say is, okay, the first instance, what do we see? And what we see is, okay, we have, it looks like a plain text line called secret, and then after that we have something that looks like an ELF file copied, okay? Well, it turns out that secret is the password used by the Bernai. So we've just recovered the password, and at that point with the password it's fairly easy to then start reverse engineering that Bernai binary. Next question is, okay, well what did they do once they ran it? So we look at the next process that ran under malware, and this is actually fairly interesting. It starts its life out as UID 500 and under the name malware, and finishes its life as UID 0SH. Now, I'm no expert in forensics, But I'm pretty sure that was when they gained root access. So we can look here, in fact, and what we see is the keystroke log, the full keystroke log of the activity immediately after the user gained root access. And so it turns out this was just me breaking into my own machine, so nothing interesting happened, except what we can see, independent of the UID that's being recorded, at some point there I do a make dir inside of Etsy, so pretty much we can tell it's the person had root access. We take a step back to the analysis questions. Well, pretty much we answered them all. We were able to recover the file malware. We were able to figure out that the password was secret to the burn eye. And we were able to identify the exact timestamp at which they gained root access, and what process ID and even what file descriptor they used to gain access. Okay. That's a pretty long way for us to go in 1 year. I mean, the initial version we had of Sebek basically dumped to a flat file that we parsed with some Perl scripts. This new web interface allows for a lot faster browsing of this forensic data, and it's actually, I've been very excited about it because it makes my life a lot easier when somebody starts using session encryption. Some of the current limits, though, and some of these have existed for a while. Primarily, the first one is, well, we use UDP, so that, of course, means that our communications channel is not reliable or connection-oriented, so we're going to lose data periodically. And there's really nothing we can do about that. Nothing is perfect, and there are ways, if you're good, of figuring out that Sebek's on a host. And I don't know if I won't get into those today, but I think at some point in the future, that'll be a fun topic in and of itself. That basically gets into the core of how you hide code in kernels. And that's a whole generic topic that's way beyond this, I think, context. The next thing we have is, well, we collect a lot of data. A surprising amount of data. If you can imagine running this system on, let's say, a host running KDE, right? Any kind of activity in the X environment is being recorded, so it generates a large volume of data, much of which may not be of any interest to you whatsoever. And so that gets sort of to a future desire, which is a way for people to express what they're interested in. Because right now, we play it safe rather than being efficient, because if you are filtering within the kernel module, and the source is out there publicly available, someone will identify how you're doing the filtering and then immediately try to hide whatever they're doing by, if you're only looking for let's say the SCP binary, right? Well, if you move the SCP binary to something called not SCP, it's not going to get recorded. So you want to be careful about how you constrain the amount of data you gather. And the safest place to do that is post-processing on the server, not within the kernel itself. The last thing we have a problem with right now as it stands is that because Linux is a kernel, because Sebek on Linux is a kernel module, we have a problem where if somebody causes the system to panic, just say, or reboots the system anyway, it doesn't automatically get reinstalled, which is a bit of a flaw. I have a feeling that there'll be a version that comes out that probably can be patched directly into the kernel. It's not a module, and I think that'll probably make that problem go away. So again, future says, compile directly into the kernel, make harder to detect, and start working on anti-Sebek techniques. So this is getting a lot like, was it Maxwell Smart and all that stuff. I mean, it's going to get ludicrous, I think, at some point if we keep at this, but it's a fun mental game. And primarily, the other thing we need to do is get a better facility for people to express what they need to look at. And then lastly, and we've made big gains in this in the last 3 weeks with the web interface you just saw, improved data analysis. Where you can get Sebek? Well, right now there's an older version off our website, and unfortunately the URL never ever seems to show up correctly on this. But you can send me email questions at ebalis@iu.edu. And also, this newest version you saw with the web interface will be available, I'm guessing within the next 2 weeks. And certainly, I would like to have all the versions we have coming out available by Black Hat Federal. So at this point, any other tools that we're talking about, just to give you a reference there, they're all off the Honeynet Project website, this URL. So whether it be Sebek, the CD-ROM, the RC firewall script, it's all going to be recorded within the tool section of the Honeynet Project website. Okay, I don't know. I think Lance, now we're in the pages that vanished earlier. I don't know if we want to get into those right now. So that's all I have to talk about for Sebek right now. I don't know what you want to discuss, Lance, at this point. I'm going to hand it over to Lance, though. Yeah. Okay, yeah, actually, we can do some question answering time right now if okay, so what you end up doing is the call we're making is I think it's called hard start transmit, hard start exmit. You have to, there's a spin lock associated with every device driver. And so you have to basically gain access to the spin lock, do your business, and let go of the spin lock. And so that way, there actually can be multiple consumers or users of that resource, and it's actually safe in a multi-user environment. Yeah. Yeah, proc is oblivious. My understanding is oblivious. Yeah, once it's off the linked list, it's pretty much, unless the only way you're going to find this puppy is by digging around inside memory, which people can do. But, yeah. I have not done port forwarding, but like I say, basically it gets all read data. So the hardest part is figuring out, I should say hard. The real task comes into figuring out how to parse the data once you gather the data, figuring out what you're looking at.
It follows the creation of threads as like the SSH thread like that.
Well, yeah, it's going to record every read call independent of what process ID, but it does, as you can saw, the web interface has the ability to it detects when for a given, pretty much keyed on the PID. So if things happen, if there's a fork or a command name change, it does do some amount of tracking in that regard. And I think one of the future enhancements would be sort of the ability to do a tree, like an execution tree of some sort, and that may help enhance our analysis. But that's going to be a work in progress, excuse me. So, yes. No, I don't know of anybody running this in a production environment. Although I could definitely see the value of that, and further, with this nice data source, it would seem like that'd be a handy place to do some sort of an alternate type of IDS. So yeah, I think there's probably a use for that. I don't know anybody that's doing it though yet. Yes. We don't do that. Once you have access to the kernel, right, you can do anything you want. It's a matter of figuring out sort of a balancing stealthiness and killing yourself trying to write the code and stability. But I think you could do that, and actually we've talked about that. Alternate ways of logging independent of putting on a secondary device would be, dumping this on the serial line. There's no reason that if you do that directly that anybody would even see that activity at all. But yeah, we've talked about some alternate methods of data hiding or data export, and we may develop more in the future, but this is kind of what we have now. So, all right. Any other questions? All right, Stump. It's all you.
Okay, what we're going to do now is Rob McMillan's going to go ahead and demonstrate the bootable CD-ROM. What he's going to do is we're booting off the CD-ROM right now. I don't need that. And he's just going to demonstrate the user interface and stuff like that. What we're hoping to show you is how we've made deploying Honeynets so much easier. So what he's done right now is this, is if we go back, if you think of the image of the Honeynet, see if you can pull up the image. Just keep going back here. There you go, just keep going back. Now what he's going to do now is this. Remember the gateway. The gateway is the Honeynet management. The gateway is what allows the bad guys to come in, but controls what they do outbound. The gateway captures a lot of the traffic. The gateway is what's very difficult to build. You got to put in bridging. You got to put in IP filtering. You got to construct specialized firewall roles. You got to build storage around your IDS gateway. You got to build remote logging. There's a lot of elements you got to put in there that's very confusing. It takes a lot of work. We have an entire white paper dedicated to that. So what we've done is Rob has taken a bootable CD-ROM and it'll instantly become that gateway in all of 2 minutes. So what used to take a day, 2 days, putting everything together, should now take only the matter of time of booting up the CD-ROM and then A, configuring it, or just giving it a pre-built configured configuration file. So why don't you go ahead and plug it in and show them how that works. So what Rob's going to do is, you just booted up that CD-ROM, here's that gateway, now here's an instant Honeynet. So what we're going to do in the near future is have this ISO, the bootable CD-ROM, on our website. If you want a Honeynet, just download ISO, burn the CD-ROM, boot off CD-ROM, and you've got it going. So what Rob's doing right now is he's got VMware, he's booting off the CD-ROM, so you're seeing the process coming up right now. Now what we're actually going to have in the far future is the ISO, you can dynamically configure the ISO before you download it. So you'll be able to go to our website and say, hey, this is what my environment looks like, this is what my systems look like, this is what I want you to remotely log to, this is what I want the root password to be. The ISO gets dynamically configured to be that. Then you download the ISO and then burn it to CD-ROM. So your ISOs are reconfigured, customized to whatever you need. So when you boot off the CD-ROM like he just booted, you don't even have to configure it. It's ready to go. But Rob's now going to talk you through the process of if you booted up for the first time for the CD-ROM and the CD-ROM was not pre-configured to your specific environment.
Hi, good morning again. My name is Rob McMillan. I'm a Marine by day, and in order to satisfy my geek itch, I do this on the evenings and at night. There's a few requirements for the CD-ROM. It assumes that the hard drive is ours, so it's got to be a system that you're willing to swipe. What you see here is this hard drive is uninitialized. That is, the Honeywell CD-ROM has never seen this hard drive, so the first thing we need to do is go ahead and format the bad boy. So, all right, so a little better? All right, so this is the interface that the user gets to play with, and by default, if you press any button other than the initial setup, it doesn't let you do anything because the Honeywell's not set up yet. So again, if any of you have ever set up the RC firewall script or snort inline or snort or anything like that for the gateway, the initial setup will basically just interview you. First of all, we have to format the hard disk. It'll interview you for all your parameters for your Honeynet. So this is basically the device that's between the Honeynet and the internet. So it does all the data control and the data capture. How many of you have heard of the Fire CD by any chance? The author of Fire, William Slutsky, is the one that made the guts for this CD-ROM, which is basically still. All right, so the first thing that comes up is if any of you actually are familiar with the RC firewall, all the variables in that to set up that firewall are basically here. So you can either do it in bridge or NAT mode. By default, we usually do bridge. That file that Lance mentioned that you can either retrieve or from a floppy has those variables in it, and eventually this will be all automatic. Right now, it's all in an interview process. It's very in the developmental stages. So we found 2 NICs. Again, the requirements are the whole hard drive and now 2 NICs. You can add a third for remote management if you'd like. Broadcast. Would you like to configure a management interface? We found the 3rd NIC. What IP address we want to give that management interface so we can actually connect to it. If we want the management interface to be accessible from the internet, we can give it a gateway. If we want to give it DNS server so it actually can do it. Do we want to activate it? Do we want the interface to come up by default when we boot the machine? Also, SSH is right now the only real service that is provided on the management interface. You can set it up on any port. Usually it's a security risk to allow root to log in, so you can say no if you don't want root to be able to connect. But unfortunately, the only user we have on the CD-ROM is root, so for right now you have to say yes. Creates your public keys. Another thing that we do is once we format the hard drive, everything runs off of the CD except for the /etc and /var. So all your configuration files remain on the hard disk, and all your logs will go to the hard disk. So the next time you boot, you don't have to redo this every time. Would you like to restrict your firewall communication? So this is for the real paranoid folks that if your management interface, someone breaks in through the SSH, you don't want to let this thing talk out too much, so you can actually restrict what it can talk out on. Now for your connection limiting, any of you familiar with the Honeynet connection limiting option? Basically, once the hacker breaks into your honeypot, we only allow a certain number of connections outbound per this scale. So right now we're saying we want to allow 9 TCP connections out per hour, 20 UDP connections out per hour, 50 ICMP, and 10 of all other. And the reason we'd have the all others is because of that one exploit that it wasn't TCP, UDP, or ICMP. So the guy was able to subvert the data connection, and I don't remember what protocol. Yeah, IP protocol 11 was the actual protocol. Snored in line. Any of you heard of snored in line? Actually, just patched snored line to match the recent release of Snort 2.0.1. But we can actually enable this too. It's got a default snored in line configuration file. Hopefully in the future we'll have a way for you to tweak what you're actually telling snored in line to do. All right, it also gives you a choice to change the root password, because by default we have honey as the root password. And we want to activate the honey wall. And then it reboots and it comes up all loaded. So basically, one time's a pain in the butt because you got to go through the interview process to tell the honey wall what's where, IP addresses, and what limits you want it to do. But once that's done, we make the honeywall.conf file. Next time, it just reads right off of that file and restores your honey wall. Yes, sorry. Go ahead. I thought you said someone had a question. Yes. Right now, Sebek's mainly for the honeypot. I guess we could put the collection side on here, but it's not on here right now. The code for it is actually on the CD-ROM. We haven't done anything with it. Are there any other quick questions?
That's one of the things we're going to do. User interface is awesome. Like, just do a user interface on here.
Yeah, right now this is a dialog. It's a very limited bash scripting GUI that we can use. So we can only do very limited things. I mean, for example, I can't have multiple text boxes on the screen at the same time, as one at a time. That's why the interview process took so long. So we have our honeypot and our status of it. Here's our network interfaces. You can see we're in bridge mode and our NICs aren't ARPing. So we should be fairly invisible, our management interface and our loopback. Here's,
Why don't you back to the main menu? Explain the main menu.
all right, picky. All right, the status basically gives you all the details about your honeypot. OS administration is specifically what you can do, SSH, change your root password, things like that, reboot the machine. Honeywell administration, oops, that's not done yet. The Honeywell configuration, all those all those parameters that you put into the interview process, you can actually go in and change them one at a time. And then the documentation, Lance has actually wrote down some papers on the CD-ROM. And we have 15 minutes. I don't know if you want to go into the UI inspector. Yeah. But here's the main file that gets the whole thing going. This is the honeywell.conf file. So here you can see right now we're not reading off a floppy. We're in bridge mode. All of the variables for the Honeywell are on this file, and we can also change it, save it to your floppy if you want. The next time you can actually take this floppy and put it on another Honeywell, and it'll boot up to those configurations. Are there any questions on this? Right, you can. That's an option. Right now, we're just looking at the CD-ROM. There's a honeywell.conf default, and as you saw those variables that showed up as I was going through the interview, those were the ones that are in the default honeywell.conf file. So in the future here, we'll be able to stick a floppy in and look at the floppy, see if there's a honeywell.conf file in there, and read those variables in and allow you to change them if you want. Yes? Yes, right now it does. Etsy, the configuration and var, everything's going to be in HW for honeywell/conf. That's where these variables are going to live, and HW/var. That will be all your snort inline, your firewall logs.
Go to a command. Can you go to a command prompt?
Yeah, it's not set up that way yet.
Oh.
It's in the future. Very developmental. Yeah.
All right. If you got any more questions for him? If not, we have 15 more minutes, so I can show this real quick. We have another GUI We have all sorts of GUIs. We got a lot of stuff, and everything that we're showing you, the idea is for it to all come together on the, all to come together on the CD-ROM. All right, what you see here is Mr. Honey Inspector. What's neat about this guy is he's not only going to demonstrate how we can analyze information, but really the value of a Honeynet. What? Oh. Oops. That's probably better. Yeah, this will make the demo so much more exciting. You can actually see it. Yeah, okay, this is what we're going to do here. What you see here is this bad boy allows you to analyze all the data on the Honeynet. It allows you to analyze the data as it comes in and comes out. So what you get to see here is this. Say you want to see in your Honeynet, I want to see what the past 100 connections are on the system, inbound and outbound. So you'd click here where it says last 100 connections. What it does is it starts off showing you all the inbound and outbound firewall logs. Because remember, everything inbound and outbound of a Honeynet is suspicious by definition. So what we do here is this. You see all this information down here? That's all the inbound and outbound traffic. Now what's really neat though is because a Honeynet only captures the packets but the packet payloads, you can analyze the connections. So if you look in the far column over there, you'll see things like errand, POF, view. Well, check this out. Click on view. Say you find, well, that's a very interesting inbound connection. I want to know more about that inbound connection. So what you would do is you click on view right here, and then it brings it up, and it gives you a snort decode of that packet. Now, let's say if you want to know, well, what type of operating system did the guy send me? Passive OS fingerprinting. You just click on this, and wham, it tells you what type of operating system you're dealing with, how many hops their way, and stuff like that. Because remember, we have this capability of really analyzing what the bad guys are doing. So this gives you a bit of an idea. Now, let's take it one step farther. Let's do with searches. Since all this stuff is stored into a database, we can go down here and do an advanced search. I do an advanced search for 18 and 19 January. What happens is this, is I get a real attack. Just keep scrolling down, and then all of a sudden, you should see a lot of traffic in red. What does red mean? Red means outbound connections. Anytime your Honeynet is doing an outbound connection, you want to get very nervous. So let's go back down here and check it out. Up a little bit, up a little bit, up a little bit. There we go. This is where we first start seeing all the excitement happening. Now look at the far right. You see some of them actually have snort associated with them. Snort would mean, hey, we've got a snort alert associated with packet. So looking at the first snort alert, let's go ahead and pull that up. It says, hey, that inbound was an FTP exploit. So we now know that one of these inbound packets was FTP exploit. I pull it up. So this guy right here was an inbound FTP exploit. Notice it's green too. You'll see here why in a minute it's green. Well, then we can go ahead and analyze this type of stuff. And notice what happens is interesting after the inbound snort alert. Look what we start getting outbound. Outbound port 80, outbound port 22. I mean inbound port 22. And inbound port 80s, outbound port 80s. We start seeing all sorts of traffic. So let's go ahead and look at the very first outbound port 80, where it should be somewhere right around here. Look at the red, that's outbound port 80. Now somebody just broke into our honeypot. What's outbound port 80 most likely mean? Downloading a toolkit. So if we look at all the packet and the packet payload, bring this up, what it's going to do is show all the packets that make up that connection right there. Now if you look at that, the very first top one right there, you'll see a wget command. Basically he's going out to a web server and he's wanting to download a toolkit. Because if you look right in there, you see get char tgz, shv tar gz. Gee, I wonder what that means. That's probably a rootkit. Well, don't forget, we captured every packet and its full payload. So why not go ahead and analyze those? All right? So what we do here is this. We pull up our plugin, all right? So I'm right here, outbound port 80. He's downloaded the toolkit. So what I do now is I click on plugin. What does plugin do? Don't forget, the nice thing with a Honeynet is we capture every packet and its full payload. So it's analyzing when he went out to that website, he's reconstructing that actual rootkit he downloaded packet by packet. So you can now analyze all the bad guys' rootkits and stuff like that without going to the website, without touching the honeypot. So all I'd have to do here is just click on download, and it would give me the bad guy's rootkit. In this case, it's a Linux-based kernel rootkit that works on TCP, rset command, reset commands, things like that. And I forget, Al Huger analyzed it, I didn't bother. Now, but you can capture so much other information also. Let's keep going down. Let's look for something else red, outbound, interesting. Port 6667. Now, what would that be outbound? IRC. Let's go ahead and do the same thing. Let's take a look at it. If we can reconstruct packets and reconstruct rootkits, why can't we reconstruct conversations? Now remember, you can do all this in real time. So here we're reconstructing chats in real time. Now if they have multiple bouncers, we're eliminating all the redundancy. So now this looks a little odd. What are these guys talking about? Who are these guys? Well, what you're looking at actually happens to be Indonesian. By freak chance, I actually lived in Indonesia for about 6 months, so I speak Bahasa. But these guys aren't doing anything exciting. They're actually talking about some vacation they're going to go on or something like that. But they hacked our computer and then decided to use it to talk about where they're going to go on vacation. So here you're able to see dynamically in real time their conversations. You're able to extract this information. Now we're going to also have the same capability with Sebek, even if they use encrypted IRC or encrypted rootkits, things along those lines. What you're seeing here is just the power of point and click. You can learn everything they're doing without them ever knowing it. Question? How else is data being stored? Excellent question. What you're seeing here is in this demonstration, the GUI and everything like that's running on that layer 2 gateway. It's running on that CD-ROM that Rob just demonstrated to you. So that layer 2 gateway is capturing all that information, dumping it all into a database that's running on the gateway, and then we're querying it and looking at it through the management interface. Because as a bridge, it doesn't have interfaces to the Honeynet or to the internet. It's got a separate third interface where you can feed it data or you can communicate it and stuff like that. So everything's happening on the gateway. Exactly. Everything's being logged to a MySQL database. So we can log it to simple TCP dump files and things along those lines, but you can't query it. So we also load everything into a MySQL database for querying capabilities. So we can do things like this. Now, what's really neat, though, keep in mind is this. Honeynets can capture unknown activity. Let's look at something that's theoretically unknown. Here is an attack that snort missed. Remember, Honeynets are designed to detect the unknown. Looking at the screen, how can you easily see, even though the bad guy never initiated an outbound connection, even though there's not a single snort alert on the screen, how can you tell by looking at this screen that you've got an evil hacker that just broke into your computer? We have a successful exploit. No snort alert. IDS failed to detect it. And the snort signature database is only 4 hours old when this attack happened. Two things scream out, hey, I've been hacked. One, green. Remember, red meant, hey, we got an outbound connection, you've been hacked. So red means outbound hack. However, what happens if the bad guy only goes inbound? Green inbound, as you see here, means an inbound connection of 10 or more packets. If the bad guy's probing you, it's only going to be probably less than 10 packets. If you've got more than 10 packets, you most likely have an established TCP connection. Something bad has happened. Second, look at the far right-hand column. Look at those numbers. Byte information. That's how many bytes are made up of the transmission. So if you look in the far right-hand column over here, what you see is 100 bytes, 100 bytes, 100 bytes, 100 bytes, 500 bytes, 300 bytes, and then all of a sudden, next to the two green lines, 55K, 55K. It's kind of hard to probe somebody with 55K of bytes. Somebody probably just hacked our system and uploaded an exploit. How do we determine that? Once again, we click on View. So I go over here and I click on View, and it'll show me the packet decode using Snort. So we see here the packet decode. We're actually going to also have the capability where Ethereal will do the decodes for us. Well, if we just scroll down a bit, boom, we see the actual exploit happen. Yep, somebody launched an exploit. Now, was the exploit successful? So we keep scrolling down. Yes, the exploit was successful. Look, they're executing all sorts of commands on our system. All sorts of naughtiness is happening. Now we keep going down. Whoa, these aren't commands. They're uploading binaries. to our system? Well, once again, remember our capability for retrieving binaries from the data stream? We just scroll down, come over here, go to plugin, and let's recover it. Now, let's determine how good our hacker is. This was a Solaris x86 honeypot he broke into. In fact, it was a virtual Honeynet running on my computer. So he just hacked the Solaris x86, actually Solaris x86 2.8. But by recovering the toolkit, we can get actually a better idea of what type of capabilities this attacker has. Why? How? Because by analyzing the toolkit, we'll see what they have uploaded. We'll see here now. It's taking a moment because what's happening is it's going through every byte of that TCP dump, rebuilding it, and then it's going to give it to us here in a minute. Hopefully here. Boom. Now, if he hacked the Solaris x86 honeypot and then uploaded his rootkit, what's wrong with this rootkit? Wrong architecture, Spark. So what we most likely have is a group of kiddies, by the way, this attack came from China, is a group of kiddies launching, scanning, attacking, probing stuff, looking for computers, any vulnerable Solaris computer, hacking into it. The exploit, is not architecture dependent. It can exploit x86 or it can exploit Spark. But the rootkit is Spark. So the bad guys are assuming any Sunbox they break into must be a Spark box, but in this case was Solaris x86. So here's a group of attackers who didn't bother looking or determining what type of system they have there. So the whole thing that the Honeynet Project's trying to do is develop technologies that make it much easier, much more effective in detecting what the bad guys are doing. But we're also trying to develop technologies where it makes it easier for you to analyze that data and derive value out of that data, like we have here. So our whole hope here is, A, to take all these technologies we developed, Sebek 2, Snort Inline, all this stuff, and to combine it onto a simple, single-to-use, bootable CD-ROM that you can simply download from our website, have it pre-configured and all sorts of stuff. So we're getting to the point where not only is one Honeynet possible, but 50 or 100 Honeynets are possible. I've got to finish up here because we're all done. Actually, I don't think do we have time for questions, or are we dead? All right, we can go with 2 questions. Question. Oh, okay, this afternoon's on honeypots. Not just Honeynets, but honeypots, honey tokens, honeyD, Spectre, honeypot farms, all sorts of new technologies. So it's very different. And one more question. Either that or beat us up. All these guys, all these developers will be at the booth all day. All right, other than that, let's go ahead and finish up. Thank you so much. Happy hunting.